Right. This is in continuation to our previous lectures where we were doing preparation of haloalkanes. Now in this video lecture we would be looking into two important reactions. Right. First is preparing haloalkanes by halide exchange method. Right. And second would be your Hunts-Dicker reaction, where we will look how we can prepare the haloalkanes from silver salts of fatty acids. So first would be halide exchange method. Halide exchange, as the name says, what exactly you understand? Halide exchange method. Halide stands for your chlorine, bromine, iodine, fluorine. So halide exchange means you exchange chlorine for bromine, iodine for fluorine. This is all, right? One halogen is exchanged for other, right? So using this reaction we mainly prepare your bromoalkane, your iodoalkanes and your fluoroalkanes. Let's see first iodoalkanes. We know that it is difficult to prepare iodoalkanes by direct iodination. If you remember, in the first lecture of this series of preparation of alkyl halides, we have seen that reaction of halogens with iodine is reversible reaction, right? Whereas we can use iodic acid, right, which is an oxidizing agent. It oxidized hydrogen iodide to form iodine in water, but still it's difficult to carry out, right, because it's a reversible reaction. So what we do is we can prepare iodoalkanes using halide exchange method, right? In halide exchange method, what we will do is we will take, say, a chloroalkane, right, and treat it with sodium iodide. We take a chloroalkane, right, and treat it with your sodium iodide. Sodium iodide has iodine, it has chlorine, right? In the presence of acetone, halide exchange will occur, right? We need to prepare iodoalkane. Iodoalkane. So this iodoalkane would be prepared by halide exchange, where this chlorine would be exchanged with this iodine, right? So RCH2, chlorine is exchanged with iodine. What you get is this is your iodoalkane plus your sodium chloride, right? This is how this reaction is being done, and this reaction is known as Finkelstein's reaction, right? Let's take one example, right? If in place of R we'll just take ethyl chloride, CH2, right? It will react with sodium iodide. When heated in the presence of acetone solvent, it will form CH3. Halide exchange will take place. This Cl would be exchanged with this iodine, CH3 CH2I plus sodium chloride, right? This reaction, this halide exchange, this reaction for the preparation of iodoalkanes is known as Finkelstein reaction, right? This is known as your Finkelstein's reaction, right? Now we can prepare fluoroalkanes also by similar reaction of halide exchange, right, using reaction that is known as Schwarz reaction. We call the reaction for the preparation of fluoroalkanes, right, as Schwarz reaction, right? In Schwarz reaction, what you will do is you will take a chloroalkane and treat it with antimony tribromide, right? Antimony trifluoride. Since we want a fluoroalkane, we will treat it with antimony trifluoride in presence of the salt of an antimony, right, in which antimony has +5 valency, right? Let's do this reaction so that we can understand. You take a chloroalkane, CCl4. This is a chloroalkane, where in methane all hydrogen atoms are replaced by your chlorine atom, plus you have SbF3, right? Since you are preparing fluoroalkane, so SbF3, right, we do this in the presence of a salt of antimony, right? It would be SbCl5, where your Sb antimony is in +5 stage. You can see the valency of antimony is 5 plus 5 here, since the formula is SbCl5. So it will form here in this reaction, product that will get formed is CCl2F2. Right, this is the product that gets formed. Right, you write it at CF2, you can write SbCl3. You can write it like this also, CF2Cl2. This is your freon gas, which is used, this gas is mainly used in refrigerators and air conditioners. Right, nowadays this is not used in refrigerators because it destroys ozone layer. Right, due to which its use is discouraged because it destroys ozone layer. Right, so this is your fluoroalkane. Right, just remember this is your fluoroalkane, and it's prepared from chloride. So this is your halide exchange method, and this reaction is known as Schwarz reaction. Right, for the preparation of fluoroalkanes. Remember, for the preparation of fluoroalkanes we go for Schwarz reaction. For the preparation of iodoalkanes we go for Finkelstein's reaction, and both these reactions are your halide exchange methods. Right, now we'll look into another reaction for the preparation of bromoalkanes. Right, for the preparation of bromoalkanes, we call this reaction as Hans-Dicker reaction. Remember the names of these reactions. It's important to remember the names. Hans-Dicker reaction. In Hans-Dicker reaction is used, this is mainly used to prepare salts of higher bromoalkanes. Right, this is used to prepare mainly higher bromoalkanes. Right, what you basically do in this reaction is that you take silver salt of higher fatty acid, right, then you treat it with bromine in carbon tetrachloride. You take silver salt RCOO CH2Ag. Right, this is your silver salt of higher fatty acid. Right, let's just arrange it right way. This would be RCH2, right, COOAg. This is the silver salt of fatty acid. Right, fatty acid is RCH2COOH. H is replaced with Ag. Right, so this is your salt. Silver salt of fatty acid is treated with bromine in CCl4. This is heated with bromine in carbon tetrachloride. Right, where it will form RCH2Br plus CO2 plus silver bromide. Right, so here you can see this, just look at these reactant and product. Here you have 2 carbon atoms, here you have 1 carbon atom. So in Hans-Dicker reaction, which is used for the preparation of bromoalkanes from silver salt of fatty acids, when treated with bromine in CCl4, and we need to heat it, right, the product that will obtain, a bromoalkane that will be obtained, will contain 1 carbon atom less than your fatty acid, silver salt of fatty acid. So this will contain 1 carbon less than the silver salt of fatty acid. Remember, right, and this method is generally used for the preparation of higher bromoalkanes. What you generally do is, since fatty acids are long chain fatty acids, right, they have long chain, right, so you can take a long chain fatty acid, silver salt of long chain of fatty acid, treat it with bromine, and your CCl4, what you will get is a bromoalkane that will also contain a long chain, right, although it contains 1 carbon atom less than the silver salt of fatty acid. Right, and using this reaction, the formation of chloroalkanes is very less and your iodoalkanes cannot be prepared. They are not formed at all using Hunt's-Decker reaction. Iodoalkanes formation is negligible. Right? Iodoalkanes possible they do not form at all using this Hunt's-Decker reaction, and the quantity of chloroalkane that gets formed is very less. So no use of using Hunt's-Decker reaction to prepare chloroalkanes or iodoalkanes. This is used to prepare only your bromoalkanes, mainly higher bromoalkanes using silver salt of fatty acid, and it has one carbon atom less, remember. Right? I hope this is clear. Just remember the names of these reactions. Schwarz reaction for fluoroalkanes, right? Then you have Finkelstein's reaction using your Finkelstein's reaction for iodoalkanes, right? These two are halide exchange reactions, right? Then you have Hunt's-Decker reaction. This is for bromoalkanes, for higher bromoalkanes, right? And chloroalkanes and iodoalkanes cannot be prepared. Iodoalkane cannot be prepared at all, whereas chloroalkanes, the amount of chloroalkanes that will get formed using this reaction would be very less, right? So we don't prefer using Hunt's-Decker for the preparation of either chloro or iodoalkanes, right? I hope all this is clear. Thanks.